You know, it really feels like AI is just evolving at, well, warp speed, doesn't it?
It really does.
Yeah.
Trying to keep up with every single development, it's
Mhm.
almost impossible. Feels overwhelming sometimes.
Totally. But today we're going to zero in on something, well, pretty significant, I think. Google's just launched their 7th gen TPU.
Ah, yes, the tensor processing unit, codenamed Ironwood.
Exactly, Ironwood. And the interesting thing is, it's specifically designed for AI inference,
Hmm.
making the models run after the training part.
That's the key distinction here, isn't it? Inference.
So our mission today is basically to dig into this. We want to explore how powerful Ironwood actually is. We'll even compare it to some top supercomputers.
And break down the technical upgrades from the last generation, Trillium, plus this whole age of inference idea Google's talking about.
Right, how does Ironwood fit into that? And maybe touch on, the implications for AI development, the competition.
Absolutely. The goal is to cut through the, let's say, the dense technical stuff and give you the key takeaways, why this actually matters in plain terms.
Perfect. And just quickly, a heads up for everyone listening.
Oh, right. This deep dive is purely for informational and entertainment purposes. It shouldn't be taken as professional advice.
Think of it as a fun and informative starting point. We really hope you enjoy it.
Exactly. A fun starting point we hope you enjoy.
Okay, so let's jump right in. This age of inference concept, it sounds like quite a fundamental shift. What's the core idea there?
It really is a significant shift, conceptually. Think about how AI often works now. We give it data, it gives us back something,
Yeah.
an interpretation maybe. It's kind of responsive AI.
Right, it reacts to what we put in.
Exactly. But the vision for this age of inference is more proactive AI. Instead of just responding, the AI is meant to actively go out, retrieve information, generate its own understanding almost.
Anticipate or provide insights without being explicitly asked in the same way.
Precisely. Delivering insights and answers more autonomously.
Okay, so Ironwood is engineered specifically for that kind of proactive future.
That's the idea.
Yeah.
It's built to handle the immense computational load these more advanced sort of thinking models require.
Thinking models, like LLM.
Like large language models, yes.
Hmm.
But also things like mixture of experts models, MOVIs, and AI architectures designed for, well, much more complex reasoning.
And these models need serious power
Right.
and fast data access.
Huge amounts of power and incredibly quick access to vast data sets to work proactively like that.
Okay, that paints a clearer picture. So to actually power this age of inference, Ironwood must be, well, pretty beefy. What kind of scale are we talking about?
The scale is quite remarkable, honestly. Ironwood comes in different setups. You can have like 256 chips
Okay.
or scale up to a massive 9,216 chips, all linked together with this super fast interconnect, and they need liquid cooling.
Wow, 9,216 chips. That sounds intense. What about power draw?
Yeah, the larger configuration, it can pull close to 10 megawatts of power.
10 megawatts. That's a lot of electricity. But okay, what does that mean in terms of raw computing power? The numbers.
So a single Ironwood chip, its peak performance is around 4,614 TFLOPs, trillions of calculations per second.
Okay, TFLOPs, big number.
Yeah.
But the whole system, the 9,000 plus chips.
Right, that's where it gets wild.
Yeah.
That system reaches a staggering 42.5 exaflops.
Exaflops. Okay, that's another level entirely. Can you put that in context for us? 42.5 exaflops means?
Yeah, it's hard to wrap your head around, but Google puts it this way. That 9,216 chip Ironwood pod has over 24 times the compute power of the current #1 supercomputer on the top 500 list.
Wait, 24 times the power of the world's fastest supercomputer, the El Capitan system.
That's the comparison they make, yeah. El Capitan is around 1.7 exaflops per pod, they say.
Huh?
Ironwood's at 42.5.
Wow. Okay, so one AI system outperforming the top supercomputer by that much, that's almost hard to believe.
It really shows the specialization, doesn't it, how focused AI hardware has become. And it's not just the chips themselves, it's part of this AI hypercomputer architecture Google talks about.
What does that mean, the hypercomputer part?
It means they've optimized everything to work together, the hardware, the Ironwood chips, and the software, like their pathway system.
Ah, pathways. We'll get to that. So it's a whole stack approach.
Exactly. It lets developers really harness the power of potentially tens of thousands of these Ironwood TPUs for their biggest AI jobs.
Okay, so it's massively powerful, massively scalable. Got it. But drilling down a bit, what's happening on the chip that makes it so good for AI inference specifically?
Well, at its core, it's all about optimizing those tensor computations. Think of them as the basic math operations AI models do constantly.
Right, the number crunching.
Yeah. Ironwood's design tries to minimize how far data has to move on the chip and cut down delays, the latency, so calculations happen incredibly fast.
Streamlined for AI thinking, essentially.
You could say that. And then there's the network connecting the chips, the ICI, inter-chip interconnect, very high bandwidth, low latency, so all those thousands of chips can coordinate effectively.
Makes sense for distributed tasks. Anything else unique on the chip?
There's also something called sparse core. It's like a specialized accelerator, originally for handling huge amounts of data in things like ranking and recommendations.
Like search results or suggesting videos?
Exactly. But interestingly, they say they've now expanded what sparse core can do, making it useful for financial modeling and scientific research too.
So broader applications than just typical web AI tasks.
Seems so. And we should probably mention Pathways again here. That's the software layer from Google DeepMind.
Right, you mentioned it with the hypercomputer architecture.
Yeah, it's what lets them actually spread these massive AI computations across lots and lots of Ironwood chips, even potentially scaling beyond one big pod if needed. Makes it easier to manage that huge scale.
Got it. Okay, so Ironwood is Gen 7. How does it compare to Gen 6? Trillium. What are the big improvements there?
Yeah, the jump from Trillium, which was only announced last year, is pretty significant. One of the headline figures is power efficiency.
Ah, important with that kind of power draw.
Definitely. Ironwood apparently delivers twice the performance per watt compared to Trillium. That's a big deal for operating costs and sustainability.
Twice the performance per watt. That's substantial.
And if you look back further, they say it's nearly 30 times more power efficient than their very first cloud TPU from back in 2018. Shows the progress.
Wow, okay. Huge efficiency gains. What else improved over Trillium?
Memory is another big one. Each Ironwood chip packs 192 gigabytes of high bandwidth memory, HBM.
192 gigs per chip. How does that
It's a
compare?
6 times more HBM than Trillium had. 6 times.
Okay, that's a massive increase. What does that allow?
It means the chip can hold much larger AI models or bigger chunks of models and data sets right there in its fastest memory. Reduces the need to constantly fetch data from slower storage.
So less data shuffling, faster processing for bigger models.
Exactly. And it's not just the amount of memory, it's the speed, too. The HBM bandwidth, how fast it can access that memory, is 7.2 terabytes per second per chip.
Whoa. And Trillium.
That's about 4.5 times faster than Trillium's HBM bandwidth. Crucial for memory-hungry AI workloads.
So way more memory and way faster access to it. Sounds vital.
Absolutely. And one more key thing. The interconnect between the chips, that ICI network we mentioned,
Yeah.
its bandwidth has also been boosted. It's now 1.2 terabits per second bidirectional between chips. That's about 1.5 times faster than Trillium's ICI.
So faster communication between the chips, too, helping
Yeah.
coordinate those huge distributed jobs.
Precisely. It all adds up. More power, much better efficiency, vastly improved memory capacity and speed, and faster chip-to-chip communication.
Okay, it definitely sounds like a significant leap. So what does this all mean for the wider AI world, especially thinking about, the elephant in the room, NVIDIA?
Right, the NVIDIA comparison. That's
Yeah.
always the question, isn't it? There was some chat about this online, places like Reddit.
What's the general feeling?
Well, the consensus seems to be that it's unlikely many customers will suddenly ditch NVIDIA GPUs for Google TPUs directly. That's not really the market.
Because Google doesn't sell the chips directly, right?
Right. Ironwood is primarily for Google's own use, powering things like Search, YouTube, and their Gemini models, and for customers using Google Cloud.
So it's more about Google's internal advantage.
Exactly. It lets Google run their AI systems potentially faster and cheaper. This vertical integration, designing the chip and the AI models together, gives them a potential edge in cost and performance for their services.
Makes sense. And the specialization aspect. TPUs versus GPUs.
Yeah, there's definitely the argument that TPUs, especially Ironwood with its inference focus, are becoming highly optimized for running AI models efficiently.
Whereas GPUs are more general purpose, though very good at training.
Kind of. NVIDIA's GPUs are incredibly powerful and versatile and dominant in AI training. But for inference at massive scale, especially for these huge models, some argue TPUs might be pulling ahead.
So different tools for potentially different parts of the AI lifecycle, training versus running.
That's a reasonable way to look at it.
Mhm.
It's hard to make direct spec-to-spec comparisons without independent benchmarks, which we rarely get. But Ironwood's design choices scream inference optimization.
Especially for those big models needing lots of memory and fast interconnects.
Exactly. Models with large context windows, for instance.
Okay, so it's about Google powering its own ecosystem and cloud offerings, potentially better or cheaper than relying solely on external hardware.
That seems to be the core strategic play, bolstering their internal capabilities and their cloud platform's AI offerings.
And you mentioned this isn't just a chip launch in isolation. It's part of a bigger picture.
Absolutely. It slots into that AI hypercomputer architecture, the whole hardware plus software system. And remember, Google already runs its top models like Gemini 2.5 and AlphaFold on TPUs.
Right, so this underpins their flagship AI work.
And the Ironwood announcement came alongside a whole bunch of other AI news from Google I/O, didn't it?
Oh, yeah, like what?
Things like Gemini 2.5 flash a lighter, faster version, new models for text to music called Lyria, updates to their video model, VO2, and image editing, Imagen 3, audio understanding 2 with Chirp 3.
So Ironwood is kind of the engine driving all these new AI applications and features they're rolling out.
That's the picture they're painting. A powerful, efficient engine designed for this broad ecosystem of AI tools and services.
And they're thinking about the responsible AI side too, you mentioned.
Yes, they highlighted their synthite technology. It embeds invisible watermarks into AI-generated images, video, and audio from their models like Imagen, VO, and Lyria.
Ah, for provenance. Knowing if something was AI generated, that's increasingly important.
Definitely a key focus area across the industry.
Okay, so let's try and wrap this up. If someone's listened this far, what are the absolute key takeaways about Google's Ironwood TPU?
Well, I'd say, first, it's a major hardware advancement, specifically targeting AI inference, making trained models run efficiently at scale.
Right, the age of inference engine.
Second, it's incredibly powerful and scalable. Remember that 42.5 exaflops figure, way beyond current supercomputers in that comparison.
The sheer scale is mind-boggling.
Third, huge improvements over the previous gen, especially in power efficiency, twice the performance per watt, and massive boosts in memory capacity and speed, plus faster chip connections.
More efficient, more memory, faster talking between chips. Got it.
And finally, it positions Google to potentially run their own AI services in cloud offerings faster and cheaper, really enabling that next wave of more proactive AI applications.
It really is fascinating to think about what this kind of dedicated inference horsepower unlocks. It makes you wonder.
What kind of possibilities?
Yeah, like with this specific focus on inference and just the sheer scale of something like Ironwood, what new kinds of maybe always-on proactive AI experiences do you think might become possible? For the listener in their near future, how might this shift the way we all interact with technology day to day? Something to chew on, isn't it?
It definitely is a great question for everyone to ponder.
Absolutely. Well, if you found this deep dive into Google's Ironwood interesting or insightful,
Please do give us a like, maybe subscribe if you haven't already.
yeah, and share it with anyone else you know who's curious about where AI is heading, and we genuinely love to hear your thoughts.
Drop a comment below. Let us know what you think or if you have any follow-up questions.
Thanks so much for joining us for this deep dive.